Hello, a student asked about this question on the discussion board, so I thought it faster for me just to make a video. There's two things. This is the one problem I referred to in lecture where I said there's one problem in the last 10 years where someone asked about this particular Taylor series, and this is the question, so somebody found it. This particular Taylor series looks like you might want to do the product of two Taylor series, because we know those. The problem is multiplying Taylor series doesn't work very well because it's way worse than a monkey face. Here's what I mean. I'll just show you really quickly. This series, if you're worried about the x squared on top, we'll deal with that in a second. So this would be bad to expand. It's not an impossible, and there's various things you can conclude from this, but it's not nice. So multiplying Taylor series tends to not work very well. But this is the one in class that I mentioned. It appears on one old test, there was a way we got this. So I just want to emphasize, this is a very special example. As I said in class, I would just throw this on your note sheet, and then you don't have to think about it. And if it pops up, you'll have it, blah, blah, blah. Okay, -1, x is less than 1. Okay, that's a series we know. We got the series I'm talking about there by taking the derivative of both sides. That meant the interval of convergence was the same. It's still -1 to 1, but this ended up becoming the derivative of this side it's 1 minus x to the -1. So when you bring down the negative, it becomes -2, and the negative comes out because of the chain rule. So you end up with this. The derivative of that should be 0 plus 1 plus 2x plus 3x squared, and so on. And if you want to write that down in a pattern form, dot 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 is equal to the sum from k equals 0 to infinity of kx to the k minus 1. Now, a couple little technicalities. I wouldn't be this picky on a test, but if someone wanted to be picky, they might say, well, you can't have 0 because it makes this exponent a negative. You see what happens. This is k equals 0. This is k equals 1. This is k equals. So there's not actually any negative exponents. You just get a 0 there, but this k is a 0. So some people would write this as the sum from k equals 1 to infinity so that we don't have that problem. Occasionally people do something funny, which is they replace k minus 1 with some other letter like I, and then they write x to the I, and then they write, well, this is 1 less, and then they write the sum from I equals, let's see, what would it be? I equals, oops, I made a mistake. Let me fix my mistake. This is not 1 less, it's 1 more. I plus 1 on the sum from I equals 0. So sometimes people get confused. This is the answer that I have written up here. It's just a question of how we want to start our counting. Do I want to call this I equals 0, or do I want to call it k equals 1? Both of these things give the same thing. Okay, so both of these would be acceptable answers. And to tell you the truth, I would give this full credit too. Okay, so there's not full credit, because that's just the Taylor series for this. What did I forget? I forgot the x squared. But that's easily to remedy. So if you do x squared times a series you already know, what does that do? Well, if you just did it here, it's going to multiply this times x squared. This one's going to be x squared plus 2x cubed plus 3x to the 4th. So it just increases all the powers by 2. If you wanted to write that notation, again, choose your favorite way of writing it. Kx to the k plus 1, that would be fine. You could write it the sum from k equals 0 to infinity, because that first one is 0. That would also be correct. If you're using this I notation, I plus 1, x to the I plus 2. All of those are acceptable. Again, when it comes to the notation, there's often lots of ways you can write it, but this is the only answer right here. Okay, separate from that, and this is part of why I decided to make a video, I will do something like this in class tomorrow, but this is a pattern question. This is requiring you to think about things in two ways. Back when I was first introducing Taylor series, I mentioned this, but let's go through the details. So another way to do the Taylor series is to find the pattern by using derivatives, right? So you plug in 0 plus you get the derivative times x plus you get the second derivative, but you have to divide by 2 factorial x squared plus the third derivative, and you divide by 3 factorial x to the third, and you just keep going. And if we'd have done that, it should have come out to be the same as this. In fact, this must have been 0, this must have been 0, and if you wanted to think about this a little bit, in order for this to be 1, that means that f double prime of 0 had to be 2. If you want to think about this a little bit, in order for this to be 2, you're going to have the third derivative at 0 over 3 factorial has to be 2. So that means the third derivative had to be 3 factorial times 2. And in this way, you can sort of work backwards to find the derivative. That's what this question is asking. So this question is asking, what happens when you get to x to the 100? So the next time you see a question like that, that's really all you have to think. When you get to the 100, it should be the 100th derivative at 0 divided by 100 factorial. And that's not helpful except for the fact that we already know the pattern. So the question we're asking ourselves is, what happens when this power becomes 100? What's going to be in front of it? Now you can do that in a number of ways. You could try to figure out when this is 100, which would be when k is 99. Be when this is 100, which is when k is 99. When is this 100, which would be when I is 98. But all of them give you the same thing. They tell you what's going to happen. It's going to be x to 100, and in front of it is going to be a 99. And that's all you need to answer this question. So the question is, what has to be true for those to be the same? Because they should be the same. And so then you say, the 100th derivative, I know it's kind of funny when you first see it, divided by 100 factorial has to be 99. And the question was asking what the 100th derivative has to be. The 100th derivative has to be 99 times 100 factorial. And you just stop. Don't try to write that out. It's terrible. The short version is you just need to find the pattern. This is asking you to find what happens when the exponent is 100. So typically that means first you're going to solve for k, then figure out what that means this is, and then you're going to set it equal. We'll do one like this in class, but I hope that video helps deal with those two questions. Please let me know in the discussion board if you have follow-up questions.